Hey there! Today, I'm going to present to you a lesson about simplifying expressions with radical exponents using radio-based instruction. But before that, please hit the notification bell for you to be updated of my next uploaded videos, and don't forget to subscribe.
Good day, grade 9 students. This is your school on the air in mathematics. We are very happy and excited to be with you as we learn through radio. I am teacher Judimar Baway from Jose Abad Santos National High School, Jose Abad Santos 1 District, Division of Davao Occidental. Please make sure that you are in a comfortable and peaceful place. May I ask, how's everyone? That's great! Listen, learn, and participate in a very exciting discussion that we will be having today. At this point, I want you to get your answer sheets, notebook, ballpen, and your module in order for you to follow our today's lesson about simplifying expressions with rational exponents. Alright, please get your module. Before we start our lesson for today, let us first have a review of the previous lesson. Can you still remember our previous lesson? Correct! About laws involving integral exponents. From your previous exercises, what are your answers? Get your module in Quarter 2, Module 4, and go to page 9. Get your module in Quarter 2, Module 4, and go to page 9. Get also your notebook and answer sheets. And let us begin. For checking, just put the check on the item number when the answer is correct. Put X mark when the answer is wrong. For checking, just put the check on the item number when the answer is correct. Put X mark when the answer is wrong. Question number 1. If y be any non-zero integer, then y to the power of 0 is equal to. If y be any non-zero integer, then y to the power of 0 is equal to A 1, A 1, B 0, B 0, C negative 1, C negative 1, D not defined, D not defined. The correct answer is letter A, 1. Question number 2. If x be any non-zero integer, then x to the power of negative 1 is equal to. If x be any non-zero integer, then x to the power of negative 1 is equal to A x, A x, B 1 over x, B 1 over x, C negative x, C negative x, D negative 1 over x, D negative 1 over x. The correct answer is, you're right, B 1 over x. Question number 3. If x be any integer different from 0, and m and n are be any integers, then x to the power of m to the power of n is equal to. If x be any integer different from 0, and m and n are be any integers, then x to the power of m to the power of n is equal to A x to the power of m plus n. A. X to the power of m plus n. B. X to the power of m n. B. X to the power of m n. C. X to the power of m over n. C. X to the power of n over n. D. X to the power of m minus n. D. X to the power of m minus n. The correct answer is letter B. X to the power of m n. Question number 4. 5 to the power of negative 2 can be written as 5 to the power of negative 2 can be written as A. 5 to the power of 2. A. 5 to the power of 2. B. 1 over 5 to the power of 2. B. 1 over 5 to the power of 2. C. 1 over 5 to the power of negative 2. C. 1 over 5 to the power of negative 2. D. Negative 2 over 5. D. Negative 2 over 5. The correct answer is letter B. 1 over 5 to the power of 2. Last question. Question number 5. The value of 1 over 4 to the power of negative 2 is the value of 1 over 4 to the power of negative 2 is A. 16. A. 16. B. 8. B. 8. C. 1 over 16. C. 1 over 16. D. 1 over 8. D. 1 over 8. The correct answer is letter A. 16. How many correct answers did you get? I hope you answered all the tests correctly. Later on, we will be having a short quiz. Don't worry, I'm sure you will be able to answer all the questions. Just listen very carefully in all the discussions. Now, I want you to get 1/4 sheet of paper and simplify the following expressions in page 2 by applying the laws of exponents. Match column A to column B and write the corresponding letter to the item number below to reveal the secret word. I'm so excited to know what the secret word is. Let us start. Number 1. X to the power of 3 times x to the power of 8 is correct. X to the power of 11. Number 2. Open parenthesis. X to the power of 3 close parenthesis to the power of 2. The correct answer is x to the power of 6. Number 3. Open parenthesis. 2a to the power of 3 close parenthesis to the power of 2. The correct answer is, you're right, 4a to the power of 6. Number 4. 4x to the power of 3 times 2x to the power of 3. The correct answer is, you're right, 8x to the power of 6. Number 5. Y to the power of negative 7. The correct answer is... You're right again! 1 over y to the power of 7. Number 6. X to the power of negative 6. The correct answer is... Correct! 1 over x to the power of 6. Number 7. X to the power of 2, y to the power of 5 over x, y to the power of 4. What's your answer? You're right! X, y. Were you able to identify the secret word? Let us reveal it. The correct secret word is... You're right! Rational. Go to page 3 and let us study. Look at the expressions given. You have there 4 to the power of 1/3, x to the power of 1/2, 25 to the power of 1/3, y to the power of 3 over 2, x to the power of 4 over 3. Open parenthesis, a to the power of 1/4 all over a to the power of 2/3, close parenthesis, to the power of 2. What can you observe from all these given expressions? You're right! These expressions are expressions with rational exponents. Remember, a rational exponent is an exponent in the form m over n, where m and n are integers and n is not equal to 0. Remember, if your n is equal to 0, that makes the expression undefined. Again, a rational exponent is an exponent in the form m over n, where m and n are integers and n should not equal to 0. In simplifying expressions with rational exponents, the laws of exponent may be used. So do not forget what have you learned from our previous topic, the laws involving radical exponents. For example, simplify the following expressions with rational exponent. Letter A, c to the power of 2 over 9 times c to the power of 4 over 3. To multiply this, you copy the common base, which is c, and then write c to the power of 2 over 9 plus 4 over 3. Remember, you cannot add the similar fractions, so you need to look for the least common denominator. So the least common denominator is 9. You write c to the power of 2 plus 12 over 9. Then, you add 2 and 12, the answer is 14. You copy the least common denominator, which is 9. So your final answer is c to the power of 14 over 9. Letter B, a to the power of 1/2 divided by a to the power of 3 over 10. To divide, you need to subtract the exponents. You write the common base, which is a, then write a to the power of 1 over 2 minus 3 over 10. Again, you cannot subtract the similar fractions, so you have to look for the LCD, which is 10. So what will happen is that a to the power of 5 minus 3 all over 10, the answer is a to the power of 2 over 10. Since the exponent can be reduced to lowest term, the final answer will become a to the power of 1 over 5. In your previous lesson, you have learned about the laws for integral exponents. Actually, these laws can also be applicable when dealing expressions with rational exponents or fraction exponents. Today, I'm going to present to you two rules that will help you in simplifying expressions with rational exponents. The first rule is the product rule. When two numbers with the same base are multiplied, we add the exponents. In the case of having rational exponents, we need to find the common denominator, then add the numerators, just like you are adding irregular fractions. Please see the examples in page 3. Letter A. X to the power of 1/2 times x to the power of 3/4. Remember, the exponents are dissimilar. Therefore, we need to look for the LCD of 2 and 4. The LCD is 4. So your new expression will become x to the power of 2/4 times x to the power of 3/4. Now, we can add the exponents. The answer will become x to the power of 5/4. Always check if the resulting exponents can be reduced, then reduce to lowest term. Letter B. Multiply c to the power of 3/9 and c to the power of 4/3. Again, the fractions are dissimilar. We need to look for the LCD of 9 and 3. In this case, the LCD is 9. So your new expression will become c to the power of 3 plus 12 all over 9. You add 3 and 12, the answer is 15. So c to the power of 15/9. Then, the exponent can be reduced. This must be reduced to lowest term. Your final answer will become c to the power of 5/3. Let's proceed to the quotient rule. When two numbers with the same base that has rational exponents are divided, we subtract the exponents. We need to find the common denominator of the two rational exponents. When two numbers with the same base that has rational exponents are divided, we subtract the exponents. We need to find the common denominator of the two rational exponents. Let's try the given expressions. Letter A. S to the power of 3/4 divided by s to the power of 1/2. Remember, when you divide, you need to subtract the exponents. Do not forget, if a and b are rational numbers and x and y are real numbers, then x to the power of a over x to the power of b equals x to the power of a minus b. Let's go back to example letter A. Remember that the exponent 3/4 and 1/2 is a dissimilar fraction, so you need to get the LCD. The LCD of 4 and 2 is 4, so your new expressions will become s to the power of 3/4 minus 2 to the power of 4. Now, you can subtract the exponents. That will become s to the power of 1/4. Let us try letter B. A to 1a to the power of 1/2 divided by 27a to the power of 3/10. In this case, you need to divide 81 and 27, and then you subtract the exponents of a, which is 1/2 and 3/10. If you divide 81 and 27, the answer is 3. Remember, the exponents of a are the similar fractions, so you need to look for the LCD, which is 10. Now, your new expressions will become a to the power of 5/10 minus 3/10. Now you can subtract the exponents. Your answer is a to the power of 2/10. Since the exponent can be reduced, Your final answer is a to the power of 1 over 5. Remember, if you divide 81 and 27, the answer is 3. So your final answer will become 3a to the power of 1 over 5. Can you still remember the basic parts of a radical expression? Please go to page 4 and familiarize all the parts of a radical expression: the index, the radical symbol, and the radicand. The radical symbol is the symbol of square root, indicates extraction of the root of the quantity that it follows. The radicand is the quantity inside the radical symbol. The index indicates the roots of extraction. Again, the radical symbol, the symbol of square root, indicates extraction of the root of the quantity that it follows. The radicand, the quantity inside the radical symbol. And the index indicates the roots of extractions. Expressions with exponents are in exponential form, while expressions with radical signs are called radical expressions. Again, expressions with exponents are in exponential form, while expressions with radical signs are called radical expressions. Hope you can still remember all the important points from our discussion. Now, go to page 7 and let us practice. Please answer item number 1 and number 2 of letter A. Fill in the missing parts of the solution in simplifying expressions with rational exponents. Can you answer these two given? Let's start with item number 1. Multiply a to the power of 2/3 and a to the power of 4/3. What can you observe? Good observation. The exponents are similar fractions, so you don't need to get the least common denominator. You write a to the power of 2 over 3 plus 4 over 3. You add the exponents. Your answer will become a to the power of 6 over 3. What will be your final answer? Correct! Your final answer is a to the power of 2, since 6 over 3 can be divided. Number 2. You multiply y to the power of 1/4 and y to the power of 2/3. Can you still remember how to solve this? That's great! Remember, the exponents are the similar fractions. You need to look for the least common denominator of 4 and 3, which is correct, 12. Now, you divide 12 and 4, the answer is 3. Times 1, you write y to the power of 3 over 12. Next, you divide 12 and 3, the answer is 4. Multiply it by 2, the answer is 12. Now, you can add the exponents. 3 plus 8 is equal to 11. Then copy the least common denominator, which is 12. Your final answer is y to the power of 11 over 12. Very good! Congratulations, because you still remember all the important points from our discussion. You want more exercises? Please see the attached activity sheet on the last page of your module. Answer that and submit it on our next scheduled retrieval of the modules. If you still have questions, write it on a piece of paper and let your parents give it to your teacher on the next schedule of releasing and retrieval of modules. Keep listening into our School on the Air during Monday to Friday. Hanggang sa susunod, I am Teacher Judimar Baway. Laging tandaan, ang batang may pagpapahalaga sa gawain, makukuha ang nanaisin o gugustuhin. Mag-aral, matuto, at linangin ang kakayahan mo. God bless us all. Goodbye!